All right, here is the greatest common factor. All right. And here is a definition of the greatest common factor. Now here, we let m and n be natural numbers. The greatest natural number d that divide both m and n is called the greatest common factor, and we write d as equals GCF mn. That's the definition. And a couple of methods we can find GCF. The intersection of sets method, the prime factorization method, extract common prime numbers, and the Euclidean algorithm. So here is the first method is the intersection of sets method. Now here you can see if I like to find GCF for 60 and 96, so I will list all the factor of 60. So 1 is a factor of 60. 2 is also a factor of 60. 3 is also a factor of 60. 4 and 5 and 6 and 10 and 12, 15, 20, 30, and 60. These are all the factor of 60. And then next, I will list the factors of 96. So 1 is a factor, 2 is also a factor, 3 is also a factor, 4 and 6, 8, 12, 16, 24, 32, 48, and 96. So I list all the factor of 96, and you can see which one we have a common. So now 1 is a common, 2 is a common factor, 3 is a common factor, 4 is a common factor, and then 6 is a common factor. And then we have 12 is a common factor. So now 12 is the common factor. So therefore, we find the largest factor, which is 12. So a GCF of 60 and 96 is equal to 12. Let's do another method. This method called a prime factorization method. And usually this is most US common textbook, they use this method. So to do the prime factorization method, I would take a 60 divided by prime number 2, and I will get a 30. And next, I take a 30 divided by prime number 2, I get 15. Then 15, I take a 3 divided by 3, all right? And then therefore I got a 5, right? So I got a prime and prime and prime. Now what about 96? So take a 96 divided by 2, I got a 48. Take a 48 divided by 2 and got a 24. Take a 24 divided by 2, got 12. Take a 12 divided by 2, I got a 6. Now finally, we take a 6 divided by 2, I got 3. So now, we will do the prime factorization, so-called prime numbers. The two numbers have in common and multiply one set of them to get a GCF. So did you see 2 and 2, they have common? Yes. 2 and 2, they're common. Now next is just 3 and 3, they're common, right? So therefore, we take a 2 times 2 times 3, so equal 12. So this is a GCF, all right? So let's take a look next method. The next method called extract common prime number. So you would write it down 60 here, 96 here. and you want to divide it by 2, all right? So you want to divide it by 2, prime number, you got 30. You divide it by 2, you got 48. You divide it by, okay, now 30 and 48, we both can divide it by 2. So once we divide it by 2, we got a 15, right? 48 divided by 2, we got 24. So therefore, we have 15 and 24. And then next, we cannot divide it by 2, but we can divide it by 3, prime number. So therefore, we take a 15, divided by 3, we got 5. We take a 24, divided by 3, we got 8. So in order to find out the GCF, we take a 2 times 2 times 3. So therefore, we got a 12, okay? So this is, I think so this is most of the German classroom, they will use this method. And then also, this is the way you can find, you know, GCF easier, okay? All right, now next, what about, can we do 3 numbers? Yes, we can do of even 4 numbers, all right? So now take a look, and we wanna do 4 numbers, okay? So I wanna do prime factorization method for 4 numbers, all right? So I take a 36 divided by 2, I got 18. Take 18 divided by 2, got a 9. So now next 9, I have to find a prime number. So 9, I divided by 3, I got 3, all right? Next, 24. 24 divided by 2, got 12. 12 divided by 2, got 6. 6 divided by 2, got 3, all right? So we have find all prime number. So here's prime numbers. And then 96, we divided by 2, got 48. 48 divided by 2, got 24. 24 divided by 2, got 12. 12 divided by 2, got a 6. 6 divided by 2, we have a 3. So we have prime, okay? And next, we have 144. Again, for 144, we know this is a, you know, is a 12 times 12. So we can find a prime number. We can find a prime number that be 3 and 2 and 2, and then 3 and 2 and 2. So therefore, we want to find what's the common factor. 2 and 2 and 3 right here, circle. 2 and 2 and 3, yes, right here. 2 and 2 and 3, yes, right here. 2 and 2 and 3. So we have, all right, we have to write it down 2 and times 2 times 3 times, which is equal 12. So this is a GCF, okay? Now what about if we have, we're using the extract common prime number. So we divide it by 2, so therefore we got 18. 24 divided by 2 got 12. 144 divided by 2 got 72. 96 divided by 2, 48, all right? And next, you know, we divide it by 2 again, because both we can find the divisibility rule, you know, all can divisible by 2. So we divide it by 2 again. So 18 divided by 2 got 9, 12 divided by 2 got 6, 72 divided by 2, 36. 48 divided by 2, 24. And then next, can we divide it by 2 again? No, we cannot divide it by 2 right here again. So therefore, what number we can divide it by? We can divisible by 3. So therefore, we take a 9 divided by 3, got 3. We take a 6 divided by 3, got 2. 36 divided by 3, got 12. 24 divided by 3, we got 8. So therefore, we take a 2 times 2 times 3. So therefore, this will be the GCF. Now next, it's a Euclidean algorithm. Now Euclidean algorithm, let's say I want to find the GCF 48 and 36. And how do I find? First, I take a 48 divided by 36. And then 48 is a dividend. And then 36 is a divisor. So this is a dividend. This is a divisor, all right? So when we take 48 divided by 36, how many we have to fill in this? So fill in 1 there. So therefore, I got 36. So therefore, we take a 48 minus 36, we got 12. Remainder is 12, all right? So therefore, the remainder, all right, is a 12, right? Until we find a 0, okay? So here is not 0, so we have to do it again. So therefore, this is a 0, this is a 12. So we have the 12 as a remainder, and move on to here as a divisor. So 12, okay, put on here, then 36 put on here. So therefore, we take a 36 divided by 12. So therefore, 3 times 2, 3 times 12, we got 36. Therefore, we got 0. Oh, 0. Once we find a 0 there, where is the GCF? This will be the GCF. This will be the GCF. This is 12 will be the GCF. Okay. All right. Now, what about another example? Here's another example for GCF. All right. I want to find a GCF for 378 and 180. All right. So 378 is a dividend, and 180 is a divisor. So you take a 378 divided by 180. So therefore, I feel the number is 2. 2 times 180 is 360. And then I got remainder is 18, all right? So I moved 18 to where? To here. Is what? Is divisor, right? Now I move 180 to where? To inside, put inside here, right? So therefore, you take 180 divided by 18. So therefore, the answer will be 10, all right? So 10 divided, the quotient is 10. So therefore, we have a remainder is 0. Are we done? Yes. Once we have a 0, and that means we find the GCF. That will be the GCF, all right? So the GCF will be 18, okay? All right, so now this is a Euclidean method. And next, we're gonna talk about least common multiple. Here's a definition, all right? Let A and B be natural numbers. The least natural number n, that is a multiple of both A and B is called their least common multiple. And we write n is equal LCM AB. Okay, that's its definition, all right? So how many different ways we can find LCM? Okay, again, we have 4 different ways we can find LCM. We have an intersection of a sets method. We have a prime factorization method. We have division by primes method. And then we have a Euclidean algorithm, okay? So we have 4 different ways we can find LCM. And here is also a theorem. The theorem is called, if you take a GCF times LCM, which is equal to number times each other, all right? So therefore, if I want to find LCM, I can find, once I find the GCF, all right, and then therefore, we take 2 number times each other and then divide it by GCF, I can find the LCM. All right, well, I can give you an example later on, okay? So now let's go ahead and then move on to next. We have 4 different methods we can use for to find LCM, all right? Now, LCM means least common multiple, right? Least common multiple. So the first method we will use is called the intersection of sets method. So here we have 12. Let's say I want to find LCM for 12 and 18. 12 and 18. So therefore, a multiply of 12. So multiply by 1, 12. Multiply by 2, 24. Multiply by 3, 36. And multiply by 4, 48. Multiply by 5, 60. Multiply by 6, 72, and so on, okay? So usually I will list a couple of them, you know, maybe list of 5, at least 5 of them, you know, the multiple. And then the next, I will list another 5 of them, see if I can find the LCM. So now 18 times 1 is 18. 18 times 1 is 18. 18 times 2 is 36. Times 3, 54. Times 4, 72. Times 5, 90. Times 6, 108. So now you can observe from this set of number and this set of number, which number is common. You can find 36 here is a common, right? And 36 is a common multiple. So therefore, this is the smallest multiple of 2 numbers, and have a common is the least common multiple, okay? So we have 36 is the least common multiple, okay? The next method we're gonna use is the prime factorization method. So I would take 12 and then divide it by 3, and I got 4. Now 4 divided by 2, I got 2. So I have prime number, yes. And then how about 18? 18 divided by 2, I got 9. And 9 divided by 3, I got 3, right? So therefore, you can observe 12 and 18, you know, if a number in common, you know, what number in common? Number in common, 3 and 2, 2 and 3. So we take a 3 times 2 times 2 times 3. So therefore, we got a 36. This is a prime factorization method, okay? You times all the common factor together, and then you will find the LCM. All right, let's move on to next, which is a division by prime method. So I believe, you know, when I, you know, go over the 50 item, I have talked about this before. I get at least 12 and 18 and divided by 2. Divided by 2, all right, prime number, I got 6. Divided by 2, I got 9, okay? Now next, 6 and 9, 6 and 9. 6 and 9, not, you know, both is not that divisible by 2, but we can start with a 2 here, but it has to be prime number. So therefore, I take a 6 divided by 2, which is 3. What about this? If divisible, we divide. If not, we just bringing down that number, right? If it's divisible, we divide. And if not divisible, we just simply bring down that number, all right? So 9, I'll just simply bring down, okay? And the next, 3 and 9, all right. The good news is 3 and 9, they're both divisible by one number, is 3. So now take a 3 divided by 3, got a 1. Take a 9 divided by 3, got a 3, all right? So are we down? No, we have to continue to do this because here we still have a 3, right? So here we take a bring down 1 and then we take a 3 divided. So therefore we got 2 and 2 and 3 and 3 and 1 and 1. So therefore, you know, what is the LCM? Now LCM we have is 2 times 2 times 3 and times 2, 3. So therefore we got a 36, okay? And next, how about we want to do 3 numbers. So we have 35, 44, 20, and 245. Okay, I want to find LCM for 3 numbers. So again, I can do the prime factorization method. I find all the prime number like this. And the next step is I find the common factor. 5 is, 7 is, 5 is, 7 is. They are all common factors. So therefore, we have 5 and 7 in common, all right? And what's the level of number? What's level number? The level number is 2, 3, and 2, all right? And 7, all right? So multiply all together. So we multiply all together. Multiply, take a 5 times 7, all right? And we take a 2 times 3 times 2 times 7, all right? So this would be the LCM, all right? So this is the method is, you know, first of all, you have to find what's the common factor, right? Common factor, okay, 5 and 7. And what's leftover? What's leftover? The leftover is 2, 3, and 2, and then 7, right? And then what's next? You take the common factor times the leftover number is LCM, right? So this is a prime factorization method. And next, you know, if we use this division by prime number, prime methods, and then, you know, if we start with a 5 and 35 divided by 5 and got 7, 420 divided by 84, 245 divided by 5 got 48, 49. And next, we find 7, okay? Take a 7 divided by 7, got 1. 84 divided by 7, 12. 49 divided by 7, got 7. And next, we do 7 again. And then if we divide, we can divide. If divisible, and if it's divisible, we divide. And if not, we just bring down the number, okay? So we simply bring down number with 1, divided on 12. And then, 7 divided, we got a 1, all right? Next, we have 1, 12, 1. So we still, 12 can divide by 3, we got 4. Then 4 divided by 2, we got 2. 2 divided by 2, got a 1. So we have, if you see all, I'm sorry. All right. If you see this, you know, you on the outside here, all right? So here 5 times 7 times 7 times 3 times 2 times 2, this will be the LCM, okay? And next is the Euclidean method. Now Euclidean method is this. Remember that, you know, Euclidean method is you find GCF, you take a GCF times LCM. You take a find GCF times LCM. It actually is a 2 number times each other. It's 2 number times each other, okay, times AB. So if you want to find LCM, you simply find GCF, you can find LCM, all right? For example, like this, LCM is 18 and we will find LCM 18 and 10, all right? And is equal how many? Now, first of all, you can see GCF 18 and 10, we don't know. That's assume we don't know, okay? And we still can find it now. What the GCF is. Remember, when we use the Euclidean algorithm, we put which one inside? We put 18 as a dividend, and then 10 as a divisor. So we take 18 divided by 10, and we fill in number 1, and then 10. So therefore, we got 8 remainder. But are we done for this? Can we find the GCF? Not yet. So therefore, we have to move A over here as a divisor, and then move, you know, 10 would put inside there. So therefore, 10 divided by 8. So therefore, we got a 1, remainder is 2, all right? So therefore, we got 2, right? We got 2, right? Did you see right 2, right? But 2 is not the finish up we have to divide again. So we have to divide again, so therefore we got 2 move over here and 8 move over there, right? So therefore, did you see, we had 8 divided by 2, and we had a number in 4. Oh, we got a 0. Remember, it's a 0. What does this tell you? This tell you 2 is a GCF. So therefore, GCF is 2. GCF is 2. GCF is 2. Now, the 2 number times each other is 18 times 10 is 180, right? This is 2. This is 180. This is 2. This is 180, right? So how much for this? So basically, you just take 180 divided by 2, and you can find LCM. All right. All right. So that's the 4 different methods of finding out the LCM. Okay. I hope you enjoy this video, and we will see you again next Wednesday. Goodbye.